All right, here, a calculus question. The volume of a cube is, so it's a cube. Like that, an ugly cube. A volume of cube is 125 centimeter cubes to the third power. So volume is equal to 125 centimeter cubed, and it is changing at a rate of 8 centimeter cube per second. So dv to dt is given. The volume is changing at the rate of 8 centimeter to the third power per second. How fast is the surface area changing? So dA to dt is unknown, which is they want what it is in centimeters squared per second at that moment in time. So now there are two things here. We have volume and area. So two formulas. Area of surface area, total area of sphere is equal to the cube is equal to, so it's a cube that all the dimensions are same. A, so there's 6 sides. So there's 6 sides, therefore total surface area is equal to 6a squared, because each one area of each one of them is a squared, so 6a squared. Actually, I put a for each one of them. Let's put x. These x. Let's put x. So 6x squared. And then dA to dt. So instead of SA, I'm going to just say a. Therefore, I can find the dA to dt is equal to 6x squared, derivative of that. But I don't have anything about x. I don't have rate of change of x. What I have is dv to dt. So I have to find what is dv to is volume. What are the formulas about the volume? Volume of a cube is equal to area of the base times height. Area of the base times height. That's xx times, again, height, which is x. So it's equal x to the third power. And from here, I can find relation between x and v. So so what is dv to dt? If I take the derivative of this, dv to dt is equal to, so let's go back to the volume of a cube is 125 centimeters squared, and it's changing at the rate of, so volume is changing, right? Means at the rate of, what does it mean? It means x is changing. See, I'm reading this to see that x is not constant. So x is going to change. The volume of a cube is 125 centimeters to the third power cube, and is changing at the rate of 8 centimeters per second. How fast is the surface area changing? So basically, this means this dimensions are getting very bigger, right? So therefore, this is not constant. To take the derivative, that's going to be 3x squared dx to dt. And then from here, we can find,
we have dv dt already.
Right, we have the volume. So see here, unknowns are, in this case, we have dx to dt is unknown, and this one is also unknown, right? But we can find them. Dv to dt is given, and also volume is given. So if we come back to this original formula, we can find x at any point. So at the point that it's 125 centimeters, so v is equal to 125 equal to x to the third. So what is x? X equal to cubic root of 125. right? Which is 25
5.
times 5, 25 times 5. So x equal to 5, right? So now we have x equal to 5. At the point when x is equal to 5, this is equal to 5, we have dv to dt. So dv to dt was 8 equal to 3 times 5 squared times dx to dt. So from here, what is dx to dt? Dx to dt is equal to 8 divided by 25 times 3 is what? 75. So now we have this. Now we can use this one to take the derivative of that, because the unknown is dA to dt. So that's going to be 6 times 2 is going to be 12x dx to dt, right? And then now we have all the unknowns. So dA to dt is going to be dA to dt is going to be 12 times x times 5 times the x to the x over 75. So this cancels, simplifies, you get 75, that's 15. 12 times 8 over 15. So I'll move it over here. So that's going to be dA to dt is going to be equal to 12 times 8 divided by 15. Which is 96 over 15 centimeter squared per second. That's how fast area is changing.